Basketball. The senior. Yeah, there. Oh, you're like, what? That's quick. On a Tuesday? All right, I'm going to start playing. You guys agree? Because however you cut it, it's going to be an infinite minus a constant that's infinite, right? Okay. This one. We should rewrite that to make it easier, right? You guys agree?
Yeah. I have a question.
Yeah.
When you're like working out the integral, if you're not putting like, let's say like as the limit from d goes to infinity, you're just working out the integral on the side. Like if it's an FRQ, are you gonna get like
If you put an equals with just an integral or just integral work, you'd be in trouble. If you keep it separate and then when you bring it back in, then you're okay. Yeah. Just don't connect with an equals. Yeah. Where are we at? Number 3? Oh my goodness. And I'm not exactly talking.
No, I was shushing you.
What? You guys agree? Sweet. Do you think maybe there might be a pattern as to what's going to happen whenever we have x to a power in a denominator? When does it diverge? If x is on the top? So as long as x has some power... Wait a minute, hold on. What if x was to the first power? It's ln. Right? Okay, so hold on. X. Maybe we didn't. Did we not finish it? Maybe we didn't finish it. I thought.
Oh, it converges. Yeah.
Converges. Yeah. Because check it, right?
Well, this is -1 there, right?
Oh, but wait a minute. What were our limits? Oh, we were going to an asymptote. We weren't going to infinity. I wonder if that makes a difference. So not talking about vertical asymptotes, because we have to take that one out. Not talking about vertical asymptotes. But talking about infinite bounds. Starting at 1, but technically starting at any constant apart from the vertical asymptote. If you start at the vertical asymptote, we're going to run into some issues. But whenever you have 1 over x to the p, we can call it a power series. I don't like the kind of the p, or you guys know if it's a constant over x to the p, it doesn't change anything, pull the constant out. If you have a constant over or 1 over x to the p, if p is less than or equal to 1, if p is 1, that's ln, that diverges. And if you're going to infinity with a 1/2 or a 1/3 or a 1/4, maybe I should have had you do another example. All of those are going to keep diverging. So technically, we could save ourselves some work and just be like, oh, hey, that's always going to happen, cool. And what's always going to happen if p is greater than 1? It's going to converge, and not only is it going to converge, but it's going to converge to, wait, what? Did it do that? This isn't just saying it converges, but wait, what's 1 over p minus 1? Pause, look at the bounds, careful. What'd you guys get for number 1? Diverges. I'm not going to show all the work because you did on the page before. Diverges. What'd you get for number 2? Converges to 1/3 times 1 over. Because you could pull the 1/3 out, and then you would have a 1 over x to the p, and then it's going to end up converging to 1 over p minus 1, which is 1/6. Ooh, but what about the last one? What do we have? We have converges to. Bound is different. So it would technically be, it would converge to, if this is correct. Now hold on, we'll come back to that in a second. Don't tell me what it was. I should have remembered, but I forgot. From 1 to 3 of 1 over x squared dx plus, no, negative. There we go. Plus 1 to infinity. Does that make sense? This one could be our 1 over p minus 1, which would be 1 over 2 minus 1. But the problem is that the entire thing? No, because we have this extra little piece to the bound. So not like we'd actually use that to solve this one, because the bounds are messy. It's easier just to do it by hand. But let's see if it works. So when we anti-derived, it was negative 1 over x with a negative would be positive 1 over x from 1 to 3, which would end up equaling 1/3 minus 1. Uh-oh, is that off? Just kidding. I honestly didn't remember. Thought I kind of did. Dun, 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 dun. Yeah. So, whenever you have 1 over x to the p, it will always diverge if p is less than or equal to 1. And if you have 1 over x to the p, it will always converge to 1 over p minus 1 as long as you have 1 to infinity. But if you have a constant to infinity, it will still converge, but it probably would be easier to do it by hand. Maggie?
But if it diverges, I'm kidding.
Is that okay? Okay. And what was the reason again? Because just in case you guys heard Justin with the whole 1/3 power, what was the reason again that this one converged? Wait, no. According to this, p is 1/3. We were going to the asymptote. We weren't going to infinity. We were a completely different part of area, or a completely different section of area. Does that make sense? So this property doesn't apply. Yeah, this is endeavor number. Oh, I went all the way to the beginning. Struggle. There we go. But hold on, didn't we decide to not make the last one an endeavor card?
Yeah, but we also added an
Oh.
Our number 11 was,
Yeah, so we have number 11 already. So we just take out, hey, now we're on track.
no, 11 wasn't, 11 was
Oh, okay. Yeah. Because we were one ahead, and I was having to adjust. But now if I take out the improper, then we're now back on track with endeavor number 12. Okay, cool. Endeavor number 12, long story short. Thanks, Meg. So could we apply it to this? What do you guys want to do? Do you want to do trying to apply the rule and see if you can make it work, or do you want to do doing it by hand? What do you? Okay, so I was trying to figure out which one I would do, but if you guys want to do both. So do what you want to do. Either try to apply the rule. I'm going to do that first, and then we're going to do it by hand. You guys can choose whichever way you want. We're going to see if we can make a match. That's what I'm saying. So our hypothesis that we're testing. A strict application of the rule. So Arnie might want to think more creatively if there's a more to consider with the U instead of the X. Go play by hand. We can't do a strict application of the rule. Now, we can still say, technically, as long as we can make the U and DU match, we can still say something to the effect of that this would converge because P is greater than 1. We could say that. But we have to ponder what's really going on. Now remember, this 1 over P minus 1 is based on the fact that we have just x to the power of. And every time we have x to the power of, as long as it's not 1 over x going to ln, the exact same thing is going to happen when we do power rule, in the sense of we're going to add 1 and then divide by. And when you plug it into FTC, the exact same thing is going to actually end up occurring, which is why this rule works, because it's just an x. But as you notice here, when we went to go plug in, it wasn't as simple as if it was just an x being 1 below what it was before. So in that case, we could technically change our bounds, and then I think we'd be okay with our rule. Because you're thinking just strict U sub into the rule, and to some extent that's correct. And in order to make this, like technically it wouldn't be 1 to b of U squared du. And if you guys did write that, like I did, technically we're off because there aren't U bounds. So what we'd have to do is U is equal to x plus 2, and then we'd have to say that U of 1 is equal to negative 1, and U of b is equal to b minus 2. And so if we change our negative 2, the problem is it doesn't fit our original 1 to infinity. So that's ultimately the reason why we can't strictly plug into that. Does that make sense? So it's not so much the u, it's more the problem with the bounds. And as we saw in the last example, the bounds aren't perfectly 1 to infinity. It's okay, it's still possible. We know it's going to converge based on the rule. We just don't know what it's going to converge to without doing it by hand.
So when you change your u bounds to b minus 2, there's no way that you could, like, knowing b is infinity, just make it all infinity?
I mean, ultimately, that's what you're going to do, right? Because when you plug it in, then that whole piece is going to be infinite. But we're not making that an infinity anyway. I guess you could make it a new variable c if you want. Let c go to infinity. Mm-hmm. Oh, the rule wouldn't work, though, because you still have that -1.
So you're going to do, like, the thing where you get the first piece and then oh, because it has to start at 1.
Right, and you could do that piece, but it's going to end up being the different answer anyway, so the rule doesn't really help. Yeah. Okay, so that was homework section 9.4. We have to talk as a class and figure out what's going on, because let me show you where we're at as far as our calendar. It was based on actually how last year went. We're right here. You can see all my other classes too. That's annoying. Let me just go by week. Okay. Using last year, somehow they fell behind. I think it was with, I don't know, choir retreat or I don't know, something. We fell behind. And so we hadn't really properly gone over questions. And I think they got really stuck in section 9.3, kind of like you guys might have last night. And we didn't fully go over those questions, I don't think. So we might need to cover some more of section 9.3 questions today. Did we grade it yesterday? Okay, we graded barely, and then you were supposed to bring questions today. So we can go over questions today. We did continue work on section 9.4, but here's the problem. Why was I doing that? Because technically, this should have been our today. Finish, and then, there's sections 9.1 to 9.4, which means as we go to next week, what do we have currently? The test on Tuesday with the review on Monday, and tomorrow is let's grade section 9.4 and start the review, and Monday is let's finish the review, but then we're a little bit more behind. But you don't have a test on a chapel day, which no one likes. But we're going to go over section 9.3 questions. I don't know if we're going to have enough to really warrant spending the rest of class on it. The teacher part of me is wanting to move the test to Monday. The understanding part of me is letting you choose. So we're going to get a little bit bored, and you guys are going to, I don't know. I mean, bored in some ways is good if you're able to work on stuff in class, work on homework, work on questions, so we have less to go over when you're supposed to be done. Does that make sense? Usually we have to go over things even though you're supposed to be done because you got stuck. So hopefully you'll be able to work out your questions in the meantime. But we are going to have to pick up that time somewhere, which means cutting into AP review or rushing a little bit before our mock AP. So it's up to you guys. I'm going to let you choose. Do you want the test Monday or Tuesday? Ponder for a little bit. Okay, I think it's overwhelming. Who wants it on Tuesday? Okay, so one way or another, majority rules. We're going to have it on Tuesday. So to that end, let me go ahead and show you guys section 9.4 homework. How many of you guys have already finished it completely? Okay, exactly. How many of you guys have even started it? Cool. Then, no, that's okay. That helps me out. Let me put on Google Classroom the 9.4 homework assignment. You guys can be writing it down as I pull back up 9.3. Is that cool? Okay. So that also makes sense as to why we should have the test on Tuesday if you haven't started 9.4. So let me go ahead and get that homework out. Section 9.4, I think it's homework 37? Is it 36? Did I put the wrong number down? Sorry, is it 37? Okay, my bad. Okay, now we're good? Okay, homework number 37, let me zoom in because that's really tiny. Poor Riley, who might be watching, might not. Okay. With section 9.3, guys, I'm just curious what other questions we have. Here's number 29. I'm going to leave it up here for a bit, but if there's any other ones, I'm going to go grab pictures of them just to kind of be ready and prepared to go through. 43 and 50? Okay, hold on. Let me go get pictures. I have 32, 43, and 50. Is there anything else you guys want to see from section 9.3? $11. Yeah, that might be a good idea. Just to kind of, I think the most time efficient way of doing it, and then Riley can see what these are too, just in case she has questions on them. I'm just going to see if anybody, like volunteer by volunteer, if anybody is able to take it. I'm just going to come up to the board and work while everyone's working on either 9.4, or they can be watching the questions that they have that way. We just kind of do it in a systematic approach, I suppose. So does anybody want number 11? Let me orient the board real quick to make it all nice and pretty. Yeah? All right, Maggie, come on up. The next one on deck I'm going to be looking for is number 32. Does anybody want to take 32 after? Oh. Can anybody else do number 11? Does anybody else want number 11? Because Maggie can take 32. You want it, James? Okay, James will take 11, then you'll be on deck for 32. After that, I'm looking for 43 and 50. So if any volunteers for 43 and 50, I don't mind doing them. I'm just giving you points. Yeah, you can just erase. You can just grab a spot. Let me go ahead and pause.